So in this video, we shall look at solving linear systems with three unknowns using the Cramer's rule. So we want to solve, for example, the following system. So solve for x, y, and z in the foreign system. One of the system is 2x plus 3y minus z is 5. 3x plus minus y plus z is 4. X plus 2y plus 3z is 14. Plus 3z is 14. So the first step is we write the system in matrix form. So the coefficient of x are 2, 3, 1. The coefficients of y are 3, -1, 2. And the coefficient of z are -1, 1, and 3. So this is our coefficient matrix. And the variables are x, y, and z. That's the variable matrix. And the constants are 5, 4, and 14. So to get our x, we first find the determinant with respect to x over the determinant of the coefficient matrix. To get y, y is the determinant with respect to y over the determinant of the coefficient matrix. And z is the determinant with respect to z over the determinant of the coefficient matrix. So this is what we need to work out. So let's start with the determinant of the coefficient matrix. This is the coefficient matrix. So how do we get the determinant of the coefficient matrix, which we are representing it that way? So this is the determinant of 2, 3, 3, -1, 2, -1, 1, 3. This matrix, we need to find its determinant. Now you can use a scientific calculator or Saru's rule, or you use the cofactor expansion. For this particular video, we shall use the Saru's rule of finding the determinant of a 3 by 3 matrix. So the first step is you rewrite the matrix and then rewrite it as a 3 by 5 matrix by adding columns 1 and column 2. Column 1 and column 2, so that we have a 3 by 5 matrix. Then from the top left corner, we have this diagonal that has 2, -1, and 3. If you find the product, you'll get -6. Then you add the product of the elements in the next diagonal that has 3, 1, and 1. That gives us 3 plus the product of the elements in the next diagonal. -1 times 3 times 2. and that is negative 6. So negative 6 plus 3 minus 6, that gives us 9, negative 9. Then from the bottom left corner, find the product of those elements, and this is positive 1. 1 times negative 1 times negative 1 plus the product of the elements in the second diagonal, which is 2 times 1 times 2, 4, plus the product of the elements in the next diagonal, 3 times 3 times 3, 27. If you add, you get that 2. And therefore, the determinant of the coefficient matrix is negative 9, the sum down here, minus the sum up there, negative that 2. And this will give you negative 41. So for all the determinant of the coefficient matrix is negative 41. Negative 41. Note that in all cases, the denominator is the same. That is the determinant of the coefficient matrix. What changes is the numerator. So next, we find the determinant with respect to x, so that we get to see what is this value in here. So the determinant with respect to x is the determinant of the matrix. So the determinant with respect to x, we need to replace the coefficients of x with the constants. And the constants are 5, 4, and 14. But the rest, the coefficients remains the same. 3, negative 1, 2, negative 1, 1, 3. So, and this will give us, using the Sarus rule, 5, 4, 14, 3, negative 1, 2, negative 1, 1, 3. And then repeat the first column, 5, 4, 1, 14, and the second one, 3, negative 1, 2 only. Then you find the product of the elements in this diagonal. 5 times negative 1 times 3, that's negative 15, plus 3 times 1 times 14, and that is 42, plus negative 1 times 4 times 2, that is negative 8. And this will give you negative 15 plus 42 minus 8, and that is 19. That's 9. That will give you 19. Then you repeat with this other side, negative 1 times negative 1 times 14, that is positive 14, plus 2 times 1 times 5, plus 10, plus 3 times 4 times 3, that is that 6. So 14 plus that 6 plus 10 gives us 60. And therefore, the determinant with respect to x will be 19 minus 60. 19 minus 60 is the same as negative 41. And therefore, x will be the determinant with respect to x, which is negative 41, over the determinant of the coefficient matrix. The determinant of the coefficient matrix. So you can work out the determinant of with respect to y, the determinant with respect to y, so that you get the value of y. The determinant with respect to y will be equals to the coefficients of x remain the same, 2, 3, 1. But we need to replace the coefficients of y by the constant 5, 4, 14. The coefficients of z remains the same. That is negative 1, 1, 3. So we need to find the determinant of this matrix. So still using the Saros rule, 2, 3, 1, 5, 4, 14, negative 1, 1, 3. We repeat columns 1 and column 2, 5, 14. And then we find the product of 2 times 4 times 3. That is 24, plus 1 times 1 times 5. That gives us 5, plus negative 1 times 3 times 14. That is negative 42. Negative 1 times 3 times 14 give us negative 42. And therefore 24 plus 5, which is 29, minus 42 give us negative 13. Then repeat on the other side. 1 times negative 1 times 4 gives us negative 4, plus 14 times 1 times 2, that is plus 28, plus 3 times 3 times 5, 45. And this will give you negative 4 plus 28 plus 45, 69. And therefore the determinant with respect to y will be equals to negative 39 minus 69. Negative 39 minus 69, and this is negative 82. And therefore, remember in the previous slide, y was the determinant with respect to y with the determinant over the determinant of the coefficient matrix, which was negative 41. This one will give you 2. Note that z is the same as the determinant with respect to z over the determinant with respect to the determinant of the coefficient matrix. It can be shown either using a calculator or any other method that the determinant with respect to z is negative 123 over the determinant of the coefficient matrix, which is 3. With negative 41, and therefore you get z is 3. And hence x, y, z is 1, 2, 3. And that is the Saros, the Cramer rule of solving a linear system with 3